Okay. What's coming next is equations and inequality. And first, linear simultaneous equations. And there is a horrendous buzzing sound outside, which I can do nothing about. Okay. Solve x plus y equals 10 and x minus y equals 4. In this particular case, x will be the midpoint of 10 and 4, which is 7, and y will be the number that you have to add and take away from 7 to create 10 and 4, which is 3. And thus the solution is 7, 3. So 7, 3 is the solution to x at y equals 10 and x take y equals 4. Solve 2x at y equals 7 and 3x take y equals 8. Okay, so y equals 7 take 2x. Alright, try again. Solve 2. This is very hard. Let me try again. Solve 2x at y equals 7 and 3x take y equals 8. So y equals 7 take 2x. So 5x takes 7 equals 8. So 5x equals 15. So x equals 3. X equals 3 and y equals 1. So 3 comma 1. So 3 comma 1 solves 2x at y equals 7 and 3x take y equals 8. All right. Solve 3x at 2y equals 12 and x equals 2y. So 8y equals 12. So y equals 1.5. So x equals 0.75. So 0.75, 1.5. So 0.75, 1.5 solves 2x equals y and I've forgotten. Let me try again. Three x at 2y equals 12 and 2x equals y. If 3x at 2y equals 12 and 2x is equal to y, then put 2x where y is. So we have 7x equals 12, so x is equal to 12 over 7. And y is equal to 24 over 7. So I believe 12 over 7 and 24, 12 over 7 comma 24 over 7 solves 3x at 2y equals 12 and 2x equals y. No, I have to try again. Right. Again. 3x at 2y equals 12 and x equals 2y. So if x is equal to 2y and 3x at 2y is equal to 12, then 6y at 2y is equal to 12, so 8y is equal to 12, so y is equal to 1.5. And if x equals 2y, then x is 3. So 3 comma 1.5. So 3 comma 1.5 is a solution to 3x at 2y equals 12 and x is equal to 2y. There. Next. Solve x at 3y equals 11 and 2x take y equals 1. X at 3y is equal to 11. So x is equal to 11 take 3y. So 22 takes 7y is equal to 1. So minus 7y is equal to minus 21. So y is equal to 3. And if y is equal to 3, then x is equal to 1. So 1 comma 3. So 1 comma 3 solves 2x take y is equal to 1 and something else. Something 11. x add 3y equals 11 and 2x take y equals 1. All right. Four x add 3y is equal to 18, and 2x add y is equal to 8. So if 2x add y is equal to 8, then y is equal to 8 take 2x. And 3 times 8 take 2x is 24 take 6x. So 24 minus 2x is equal to 18. So minus 2x is equal to 18. No, 24 minus 2x is equal to 18. So minus 2x is equal to minus 6. So x is equal to 3. And if x is equal to 3, then y is equal to 2. So 3 comma 2 solves 4x at 3y equals 18, and two x at y equals 6. No, 2x at y equals 8. All right. Okay, next, quadratic simultaneous equations. Solve y equals x squared and y equals x plus 2. Okay, so x squared is equal to x plus 2, so x squared take x take 2 equals 0. So x minus 2 times x plus 1 is equal to 0, so x is equal to negative 1 or 2. X is equal to negative 1 or 2 solves. X is equal to negative 1 or 2 solves. Y equals x squared and y equals x plus 2. Y equals x plus 1, and x squared at y squared equals 25. Okay, so x squared plus the square of x at 1 is equal to 25. So 2x squared at 2x at 1 is equal to 25, so 2x squared at 2x take 24 is equal to 0. So x squared at x take 12 is equal to 0. So x at 4 times x minus 3 is equal to 0, so x is equal to negative 4 or positive 3. And if x is equal to negative 4 or positive 3, then y is equal to negative 3 or 4. So negative 4 comma negative 3 and 3 comma 4 solves y equals x plus 1 and x squared at y squared equals 25. y equals 2x and xy equals 8. So 2x squared equals 8, so x squared equals 4, so x is equal to plus or minus 2. So y is equal to plus or minus 4. So 2 comma 4 and minus 2 comma minus 4. So 2 comma 4 and minus 2 comma minus 4 solves y equals 2x and xy equals 8. Y equals x minus 1 and y equals x squared minus 3x plus 2. So x minus 1 equals x squared minus 3x plus 2. So x squared minus 4x plus 3 equals 0. So x minus 1 times x minus 3 is equal to 0. So x equals 1 or 3. And if x is 1 or 3, then y is 0 or 2. So 1 comma 0, 3 comma 2. So 1 comma 0 and 3 comma 2 solves y equals x minus 1 and y equals x squared minus 3x plus 2. X at y equals 5 and xy equals 6. Now it seems obvious that we can use 2 and 3 here in either order. So 2 comma 3 and 3 comma 2. 2 comma 3 and 3 comma 2 solves x at y equals 5 and xy equals 6. Okay, the next section is simultaneous equations on graphs, which I like. Okay. State how many points of intersection y equals x squared and y equals x minus 3 have. Alright, so we can visualize this. Now, it seems pretty clear that y equals x minus 3 will be the perfect straight line through the origin from the lower left to the top right, but lower down by 3 units, and thus they don't intersect at all. Find the value of k for which y equals 2x at k is a tangent to y equals x squared. Now, if it's a tangent, then x squared equals 2x at k has exactly one solution. And for this to be true, we rearrange it into standard form. So x squared minus 2x minus k equals 0. And then we apply the discriminant, and we have to set it equal to 0. So the discriminant is b squared minus 4ac, and in this case it would be 4 minus 4k would equal to 0. So k would be 1. Yeah, k would be 1. And k would be 1 in the case where y equals 2x at k and y equals x squared are tangent. All right. State how many points of intersection y equals x squared minus 4 and y equals x, beg your pardon. State how many points of intersection y equals x squared minus 4 and y equals 3x have. Okay, so we have to solve it. Actually, we don't have to solve it, we just have to set them equal to each other. So x squared minus 4 is equal to 3x. Then solve, or rather, apply the discriminant to x squared minus 3x minus 4 equals 0. And when we do so, we get 9 plus 16, which is 25, which has 2 roots, and therefore they intersect twice. Rather, y equals x squared minus 4 and y equals 3x intersect twice. All right. Find the value of k for which y equals k and y equals x squared minus 6x plus 11 meet exactly once. Right, so y equals x squared minus 6x plus 11 is a parabola opening upwards with a y-intercept of 11, and so it's tempting to say k equals 11. However, we actually have to find the minimum point. Y equals x squared minus 6x plus 11, and let's see how we're going to do that. What we're going to use is the line of symmetry, which is minus b over 2a, so 6 over 2, so 3, and then substitute in 3 to get the value of y that we need. So 3 squared minus 6 times 3 plus 11, so 9 take 18 plus 11, which is 2. So 3 comma 2. So k is equal to 2. So I can say that y equals k and y equals x squared minus 6x plus 11 intersect exactly once when k is equal to 2. Okay. State how many points of intersection y equals x squared add 3 and y equals 2x have. So we equate them. So x squared add 3 equals 2x. So x squared minus 2x 3 equals 0. And if x squared minus 2x 3 is equal to 0, then applying the discriminant, we get a negative value, so they don't intersect at all. So y equals x squared add 3 and y equals 2x don't intersect. Okay, next, linear inequalities. Solve 3x minus 7 is greater than 8. So 3x is greater than 15. So x is greater than 5. So x is greater than 5 solves 3x minus 7 is greater than 8. Solve 5 minus 2x greater than 1. So minus 2x is greater than or equal to negative 4. So x is less than or equal to 2. So x is less than or equal to 2 solves 5 minus 2x is greater than or equal to darn it, it's already gone. Solve 5 minus 2x is greater than or equal to 1. So negative 2x is greater than or equal to negative 4. So x is less than or equal to 2, which is right. So x is less than or equal to 2 solves it solves 5 minus 2x is greater than or equal to 1. That's what it solves. Okay, next. Four brackets x minus 1 is less than 2x at 6. So expanding. So 4x minus 4 is less than 2x at 6. So 4x is less than 2x at 10. So 2x is less than 10. So x is less than 5. And x is less than 5 solves 4 open brackets x minus 1 is less than 2x at 6. Okay. Solve negative 3 is less than 2x at 1, which is less than 9. So I'm going to subtract 1 from everything. So negative 4 is less than 2x, which is less than 8. And divide everything by 2. So negative 2 is less than x, which is less than 4. And negative 2 is less than x, which is less than 4, solves negative 3 is less than 2x at 1, which is less than 9. X at 2 all over 3 is greater than or equal to 4. Solve this. Times both sides by 3. So x at 2 is greater than or equal to 12. Take 2 from both sides. So x is greater than or equal to 10. So x is greater than or equal to 10 solves x at 2 over all over 3 is greater than or equal to 4. Okay, next up we have quadratic inequalities. All right. I don't know how I'm going to do this, so I'm going to try. Solve x squared minus 9 is less than 0. X squared minus 9 is less than 0. Okay, that means negative 3 is less than x, which is less than 3. So negative 3 is less than x is less than 3. Solves x squared minus 9 is less than 0. Solve x squared minus 5x plus 6 is greater than 0. Okay, so we solve it like an ordinary quadratic, and we get the roots as 2 and 3. And x must lie outside of that interval between 2 and 3. So we can say x is less than 2 or x is greater than 3. So x is less than 2 or x is greater than 3 solves x squared minus 5x plus 6 is greater than 0. X squared at 2x minus 8 is less than or equal to 0. Solve this. Okay, so we solve it like an ordinary quadratic. So x at 4 times x take 2. That's how I factorize it. And as a result, x is negative 4 or 2. Those are the roots. And I've forgotten the conditional. All right, so I have to do it again. Solve x squared at 2x take 8 is less than or equal to 0. Solve like an ordinary quadratic, factorize, have it as x at 4 times x minus 2 is less than or equal to 0, in which case the two roots that we obtain are negative 4 and positive 2, and thus x is trapped between these inclusively, so negative 4 is less than or equal to x, which is less than or equal to 2. So negative 4 is less than or equal to x, which is less than or equal to 2. Solves x squared at 2x. X squared at 2x minus 8 is less than or equal to 0. Okay. Solve 2x squared minus x minus 3 is less than 0. Alright, so factorizing 2x minus 3 times x plus 1. So 3 over 2 or negative 1. No, 3 over 2 or negative 1. So negative 1 is less than x, which is less than 3 over 2. So negative 1 is less than x, which is less than 3 over 2, solves two x squared minus x minus 3 is less than 0. And last, solve x squared is greater than or equal to 4x. Okay, so moving the 4x over, we get x squared minus 4 greater than or equal to 0, and then solving ordinarily, we get x open brackets x minus 4 is greater than or equal to 0. Okay, so x is less than or equal to 0, or x is greater than or equal to 4. And x is less than or equal to 0, or x is greater than or equal to 4, solves x squared is greater than or equal to 4x. Okay, now inequalities on graphs. Find the values of x for which y equals x squared minus 4 lies below the x-axis. In this case, negative 2 is less than x, which is less than 2. So if negative 2 is less than x, and x is less than 2, then y equals x squared minus 4 is below the x-axis. Yeah? Okay. Find the values of x for which y equals x squared lies below the line, y equals x at 6. Alright, so you have to equate them and then solve it. and it will be the interval, the closed, the finite open interval. So x squared equals x at 6. So x squared minus x minus 6 is equal to 0. So x minus 3 times x at 2 is equal to 0. So minus 2 and 3. So negative 2 is less than x, which is less than 3. So as long as x is between negative 2 and 3, non-inclusive, then y equals x squared lies below the line y equals x at 6. Find the values of x for which the curve y equals x squared minus 2x lies below the line y equals 3. So we set them equal to each other and solve again, and consider the finite interval if it should emerge. So x squared minus 2x is equal to 3. And so x squared minus 2x minus 3 equals 0. Solving by factorizing, x minus 3 times x add 1 is equal to 0. So x is minus 1 or 3. So negative 1 is less than x, which is less than 3. And we say negative 1 is less than x, which is less than 3, solves the problem of when what? When y equals x squared minus 2x lies below the line y equals 3. Find the values of x for which y equals x squared at 1 lies above. Find the values of x for which the curve y equals x squared at 1 lies above y equals 2x at 1. So it will be the pair of open intervals, should they exist. Alright, so set x squared at 1 and 2x at 1 equal to each other, so x squared is equal to 2x, so x squared minus 2x is equal to 0, so x open brackets x minus 2 is equal to 0, so x is either equal to 0 or 2. So x has to be less than 0 or x has to be greater than 2. X is less than 0 or x is greater than 2 solves the problem of when y equals x squared at 1 lies above y equals 2x at 1. Find the values of x when the curve y equals 6 minus x squared lies above. Let me try again. Find the values of x for which the curve y equals 6 minus x squared lies above the line y equals x. So that will be the finite open interval, if it exists. So we set 6 minus x squared and x equal to each other. So 6 minus x squared equals x. So x squared at x minus 6 equals 0. So x at 3 times x minus 2 is equal to 0. So x is negative 3 or positive 2. So negative 3 is less than x, which is less than 2. So negative 3 is less than x is less than 2 solves the problem of when the curve y equals 6 minus x squared is above the line y equals x. Okay, last. Man, I am really enjoying this. It just feels like it feels better than working out. Feels great. State the inequality describing the region strictly above the line y equals 3x minus 2. Alright, so we can use a test. State the inequality describing the region strictly above the line y equals 3x minus 2. So 0, 1000 would clearly satisfy that. And so we have to simply say that y is greater than 3x minus 2. Hello. State whether the point 2, 3 lies in the region specified by x is greater than or equal to 0, y is greater than or equal to 0, and x at y is less than or equal to 6. Okay, so clearly the x coordinate is greater than 0, so is the y coordinate, and their sum is less than or equal to 6. So I would say yes. Beg your pardon. So yes, the point 2, 3 does lie in the region specified by the three inequalities that x is greater than or equal to 0, y is greater than or equal to 0, and x at y is less than or equal to 6. Okay. State whether the point 1, 5 satisfies y is less than x squared at 3. So in this particular case, we just need to ask ourselves the question, is 5 less than 1 squared at 3? The answer is no. So 1, 5 does not satisfy the relation that y is less than x squared at 3. Find the area of the region specified by the three inequalities x is greater than or equal to 0, y is greater than or equal to 0, and x at y is less than or equal to 4. So we can visualize a right triangle in the first quadrant whose base is 4 and whose height is 4, and therefore whose area is 8 square units. All right, the very last one. Find the area of the region specified by y is greater than or equal to x at 2, y is greater than or equal to 0, and x is less than or equal to 0. So y is greater than or equal to 0, that's the upper half of the plane. X is less than or equal to 0, that's the left half of the plane. And thus it's specifying quadrant 2 with the axes included. But then we have the relation that y is greater than or equal to x at 2. Alright, so the answer is 2 itself. 2 times 2 over 2 is 2. Alright, so that finishes it. So we have to check everything. Okay, 1, 2, 4. So four mistakes. Four mistakes. So we have to check these mistakes. Okay, so for 4 it's apparently 2,3. For 12, k is actually equal to -1. Apparently, we're going to check. Where's the other one? 1, 2. No, there's only 3. There's only 3. 3 mistakes. And then lastly, we have in problem 29. 0 is less than x, which is less than 2. All right, so we have to check. Yep, okay, they're correct about question 4. And they're also correct about question 12, which is surprising because perhaps I didn't physically and visually check it. That's what that means. Okay, and that makes sense for 29. So not bad, not bad. That's 32 out of 35. Not bad. All right. Now, I would absolutely love to do chapter 4, but you have to take a break and exercise. It's good for you. Thank you so much.